Chapter 13, we're going to move into the mathematics that go along with the vocabulary that you used out of Chapter 12. So the first topic is called the combined law. There were three scientists that created separate gas laws, and what we can do is actually put them all together into the combined law. And it deals with pressure, volume, and temperature. You're going to have something at station 1, and you're going to change a variable to your 2's, and you're just going to cross multiply and divide and solve for them. So P is your pressure, V is your volume, T is temperature in Kelvin. Now if you don't remember how to convert to Kelvin, your cheat sheet has it on the front side, and you have to go from Celsius to Kelvin. You have to add 273.
Yeah, it's very easy conversion, but people forget to do it all the time.
You must always convert to Kelvin before you do your math, or you will never get the answer correct, ever. Add 273. Get that number memorized, write it really big in your notes, circle it, whatever you need to do. Going from Celsius to Kelvin, you need to add 273.
Yay!
All right, so let's try a problem. We've got a sample of nitrogen monoxide, has a volume of 72.9 milliliter, at a temperature of 16 degrees Celsius, and a pressure of 104.1 kPa. What volume will the sample occupy at 24 degrees Celsius and 99.3 kPa? So what Mrs. Kelly is doing is she's gathering the information, she's making a chart. V1, P1, T1. Now the 16 degrees is going to have to be automatically converted with that 273. So she's doing this so that she doesn't ever forget again. Then she's going to make another chart and have the V2s. And P2 and T2.
No.
P2 is 99.3 kPa.
Okay, so what do we need to do with the kPa? Can we keep it as kPa?
As long as your pressures match, then you're fine to keep it. If they do not match, you're going to have to convert one to the other using your pressure conversions on your cheat sheet. The volumes is also the same way. As long as your volumes match, it doesn't really matter what they're in.
So we don't need to change this to liters, and we don't need to change that because they match over here.
Yes.
And so our answer for volume will end up being
milliliter.
Milliliters.
Yep. Now, if your problem actually asks you to what is the volume in milliliter or in liter, if it said in liter, you would have to actually convert that. So you have to read the problems very carefully and pull out your information.
Wrong one. We're gonna do 72.9 on the top because it's PV over T.
So we got 104.1 times 72.9 divided by 289 is equal to 99.3, and then you're going to have your V2 over 297. We're going to cross multiply 104.1 times 72.9 times 297. You're going to hit enter. Then you're going to use your parentheses and you're going to join together the 289 and the 99.3 to get V2 alone all by itself. As you have to get rid of all those variables on the right side of your equation. There you go.
What do we get?
Your answer is going to be 78.54 milliliter.
There's your answer. So I would say, until you get used to doing these things, always write out your V1, P1, T1, V2, P2, T2, and if they say that it's at constant temperature, or if they say it's at constant pressure, just put in ones.
Yep. So if they don't give you a numerical value and they say a constant, put those in at ones, put them into the combined law as ones, and you will be just fine.
Okay.
Good enough, huh? Not too hard. Plugging and chugging, pulling the information out of the story problem. Not only would I suggest as well to make the chart, but as you go through the problem, maybe up above, as soon as you read something has a volume of, put the volume. And if
you
it's
could just write
exactly V1, so that as you go through,
V1.
You would see those right away, and then you can pull them down into your chart, and you're not reading the problem over and over again.
Right. And the reason I like to do the chart is so that I remember to do the temperature.
Exactly. Convert that. Section 2 we're going to move into as well. Avogadro's principle is stating that at standard temperature and pressure, which is STP, you're going to see this in quite a few problems,
Yeah.
but you can automatically then use standard temperature, which is 0 degrees Celsius or 273 Kelvin, and pressure of 1 atm. So those are going to be your two values that you're going to use into the combined law to solve for the problem. The thing that you're going to need to know now is that you have a new triangle. Avogadro proposed that 1 mole of any gas at a given temperature and pressure would occupy 22.4 liters of volume. So on your cheat sheet, you're going to be right where your other little triangles of moles were, and this one's right down in the middle. So you're going to have moles, and you can go mole to volume or volume to mole. So what we're going to have to do here is we've got, using the combined law, which is your P1 V1 over T1 equals P2 V2 over T2, you're going to use that law plugging in STP values.
Yep.
So here's what we've got, because there's not a whole lot of numbers in here. So they've got to be able to pull out the information. This is using the combined law. Using the combined law, what's the volume of 7.17 gram of neon gas at 24 degrees Celsius, not a point, and 1.05 atm. So what we have to do, the volume, how to read this question. What is the volume of something grams of neon gas at? So that at is actually going to join our 24 degrees Celsius and our 105 atm together with the volume. So those are actually our 2's. So V2 is what we want to find.
Okay.
And the degrees Celsius is our 2. And the one,
Right here?
yeah, that's a T2.
Oh, there, yep. T2.
And then a P2. And we want to solve for V2. Now, we don't have any ones given to us directly in the problem. But what we do know is that we've got 7.17 grams. We can take that grams of neon, and we can convert that gram into mole.
Right.
Convert mole.
You thought we were done with
Yeah.
that stuff. We're not.
No. Keeps coming back. So we're using neon, so Ne, and we're going to have to look up that molar mass of Na.
20.
20. Fabulous.
Okay, so 7.17 divided by 20.
0.3585.
0.35.
3585. And that's moles. Now we can use the new triangle we just talked about, the liters over moles, and figure out what our, with our 22.4, figure out how many volume, what we're going to need. So what we're going to do is we're going to plug in our mole value into our cheat sheet, and it's sitting right next to 22.4, so we're going to, 22.4 mole and liter.
Okay.
Fabulous. So we know the moles. We are going to multiply that by the 22.4 to get our volume. And that's going to be 8.03 liters. That is our V1. What about our, we're missing some things.
We're missing our temperature and our pressure.
STP. STP tells you you can use that triangle, and then you know your temperature is 273 Kelvin, and your pressure is 1 atm.
Okay, so let's fill it in. We've got one. Oh, I'll just do one like that. Ignore the little mark. And then you've got volume next to it, so 8.03.
Yep.
Now on the bottom, you've got T1. Remember STP, so 273 kelvins. That equals. Let's see, our pressure is 1.05 for our P2. That's a point. We're looking for V2. And our temperature was 24 plus 273.
297.
297. It's been a long day. Okay. So now what do we do?
We'll cross multiply and divide.
Okay.
So 1 times 8.03 times 297 divided by 273 times 1.05. And we get a volume of 8.32.
Not much different.
No. Not really.
And it would be liters.
All right.